This section, we're going to learn about having a system of two equations with two variables. Here an example of one. So we're going to learn how to solve the system. How that works is that, since there are two equations and two variables, there's usually only one x and one y that when you put it in both of these equations, they will both work out. And we're trying to find what they are. The first method is the substitution method. The idea of this method is to isolate one of the variable in one of the equation and then substitute it into the other equation. So let's look at this example again. So first we'll choose one of the equation and a variable to isolate. I'm going to choose to isolate x in the first equation. So here I move the y over and then I divide both sides by 2. Now I'm going to take this x and substitute that into the second equation. So in place of x, we're going to have 3 minus 2y into the second equation. And then now I just simply solve for y from here, which y comes out to be 2/3. And now that I know y is 2/3, I can simply substitute that into this equation for x. So I put 2/3 in here as y, and then I just do the math, and x comes out to be 5/3. The second method is the elimination method. This is the method I prefer most of the time because it's usually quicker. So the idea is to match up one of the variable and cancel them. So here we are going to look at the same example again. And we first will choose which variable we want to match up. Here I'm going to match up the x. So I'm going to do that by multiplying the first equation by 3 and the second equation by -2. And here is what they're going to be. And make sure you multiply through the entire equation. A common mistake is to multiply only the x and y's and forget to multiply the constant. So now that I've matched up the x, I simply add them, add these two equations, and the 6x and -6x cancel out, and then I have 24y equals 16, and divide 24 over, I have y equals 2/3 again. And now I can just plug this 2/3 into either one of these equations and solve for the x. And x is going to come back out to be 5/3, which is the exact same answer as we got from the substitution method. So as I said, there are usually one x and one y that will work, but that's not always the case. So here we're going to consider a special case where there's no solution. So let's look at this system of equation, and I'm going to try to solve it with substitution. I isolate the first equation for y, and then I substitute the y into the second equation. And then I do the algebra, and I find out that 20 equals 10. Well, as you probably know, 20 doesn't equal 10. When that happens, there is no solution to the system, because 20 will never equal 10. So no combination of x and y can ever satisfy both of these equations. Another special case is that there are infinitely many solutions. So let's consider this system of equation. And again, I take the first equation, I isolate the y. I will substitute that into the second equation for the y. And I will do my algebra. And I come out to 20 equals 20. Well, as you know, 20 does equals 20. So this means that there are infinitely many solutions, where that means that there are more than one combination of x and y that will satisfy both of these equations. So now we're going to learn how to use system equation with word problems. Let's look at this example. It takes 2 slices of meat and 3 inches of bread to make a small sandwich. It takes 4 slices of meat and 4 inches of bread to make a large sandwich. I have 50 slices of meat and 80 inches of bread. How many sandwiches of each size should I make to use up all the bread and meat I have? These problems are really long, and sometimes it can be daunting to students. So here we're going to try to break it down into simpler steps, which you can understand how the entire thing works. So first step, we're going to identify and label our variables. After all, if there were no variables, there would be nothing to solve for. So we're trying to find out what the variables are and solve for them. Usually the final sentence of the problem will give you a hint of what they are. So here's a quote from the problem. So the last sentence says, how many sandwiches of each size, yada yada. So here, from this sentence, you can infer that sandwiches of each size are our variables. So here I'm going to make number of small sandwiches made to be x, and number of large sandwiches made to be y. You can call them whatever letter you want, but I just like to use x and y here. So now the second part, we're going to try to formulate the equation. So this is the harder part, but there's a kind of a trick to doing these problems in your class. So a lot of time, they are either a resource problem or a demand problem. For this problem, it's a resource problem. Once you identify it, you just have to remember this. Each resource or demand will get its own equation. So here I'm going to show you exactly how that works. Here is the quote from the problem, and we can see that meat and bread are the 2 resources. And here we're going to put it in a table like this. So because meat and bread gets its own equation from a resource problem, so there's a meat equation, and then there's a bread equation. Now we're going to put the meat and the bread on the side here, and then we're going to put x and y on top here like this. And from there, it's actually pretty simple. So we just say, okay, well, x is a small sandwich. So it takes 2 slices of meat and 4 inches of bread to make a small sandwich, x. So for meat is 2x. And for bread is 4x. In the same way, y is the large sandwich. So 3 slices of meat is 3y. And 4 inches of bread is 4y. Now what we have on hand, we're going to put on the right side over here of the right of the equal sign. So I have 50 slices of meat, so we're going to put 50 over here. And we have 80 inches of bread, and we put 80 over here. So now you just put a plus sign here and here, and these are your 2 equations. So now that you have the equations, now you just solve for it. And in fact, this is actually the same problem as quiz 5.2.1. So you would just do what you did there, and you would have solved for that x equals 10 and y equals 10. So since this is a word problem, we interpret our answer, which is that x is the number of small sandwich made, and y is the number of large sandwich made. So therefore, we need to make 10 small sandwich and 10 large sandwich to satisfy the conditions.